So this is example 22.1, and this is the given section. So this is an analysis problem, a part of the analysis, in fact. So it is symmetrical section 12 inch. So this is the centroid, and this is 12 inch to the top and 12 inch to the bottom. So C1 and C2 both are 12 inch. I can write them down over here. C1, C2 both are 12 inch, and the red dots that you see over here are the tendons. Okay, so there are multiple tendons, and each one of them is a 7-wire strand. So the centroid of their so each of them has certain area. Okay, there is a table for it, but right now we're just discussing that they have a certain area, total area, and the centroid of them is somewhere over here. Okay, so 7.9 inch below the centroid. This is the centroid of the whole section, and this level is the centroid of these strands. Okay, so there are 5 pairs at the middle third. At the third one, you have the centroid. Okay, so they are all same areas. Let's say. So the total area of those are it's not given, although, but what we know is the eccentricity. So E value is 7.91 inch. Okay, maybe I can write them down. Write it down over here. E is 7.91 inch. Okay. Now you have to calculate the flexural stresses at various stages at the time of transfer and when full load is acting, and compare with the ACI limits for a class U member. Okay. Class U member means uncracked member. Now the first thing to do is you have to calculate the stresses due to the pre-stressing force alone. Okay. So the first stage is at the time of transfer. All right, at the time of transfer, the stresses would be F1 at the top. F1 for the flexural stress at the top. Okay. Now we have learned that the general formula for it is minus Pi over AC times 1 minus EC1 over R square. Okay, we have just discussed it. Now at the bottom, it is F2 equal to minus Pi over AC times 1 plus EC1 over R square. Okay, E times C1 over R square. So these are the stresses due to pre-stressing action alone. Okay, so we need to consider 2 locations at the time of transfer. One are the ends of the simply supported member, and the other is the midspan. Okay, so let's first calculate these stresses. Let's first calculate these stresses. Okay, minus Pi is 158 kip. I'm going to write 158,000 pound. Okay, over. So I'm going to work in pounds and inches. So the stress would be in pound per square inch, PSI. Okay, in all cases we will work in pounds and inches. So 158,000 over AC is 176 inch square. 1 minus E value is 7.91 times C1 and C2 both are same, 12 inch. Okay, divided by R square. Radius of gyration square is 68.2. Okay, so this gives you you can confirm this answer plus 352 psi. Please confirm this answer. I want you to follow along. 350, 1.7 rounded off to 352. Okay. Similarly, you can check this. You can just go back and edit your expression in the calculator, change this to plus sign. Okay. Two one four seven. 0.17, so rounded off to 2147 psi. Okay, so this is tensile and this is compressive. Now I need you to understand that at this stage, this stress exists. So if I can just draw it over here, if this is the member, although it's not rectangular, I'm drawing the front view. So this is the length side. Okay, this is the span, and if this is the action of the P, and we have applied constant eccentricity. Okay, so at this stage, under the action of this P load only, Pi in fact, at eccentricity E, we have the stresses at the top and bottom which are constant over the length of the member. Okay, the compressive force is constant over the length, and the associated hogging moment due to eccentricity is also constant over the length. So these are the stress. So this top stress and the bottom stress are true for both the midspan and the ends, as far as the action of pre-stressing force is concerned. Okay, so this is at the ends and also at the midspan. Now, if you go to the table 22.1, go to table 22.1 of this book, Design of Concrete Structures by Nilsson. Permissible calculated stresses in concrete and pre-stressed flexural members. You need to compare these. So at the ends, if you read B and D, B says extreme fiber stress in compression at ends of simply supported members. Okay. So at the end of simply supported members, the extreme value of compression allowed is given to be. So we are going to compare something that applies to this member. So we'll come back to this, but first we want to check this. Okay. So the permissible value for this is so this is all the same for all classes of members U, T, and C. So it is 0.70 FCI prime. Okay, and FCI is the concrete strength at the time of transfer, 3750. Okay, so this is 3750. Sorry, can you repeat? 2625 psi. Okay. And this limit is if you go to part B, it says extreme fiber stress in tension immediately after transfer at the ends of simply supported members. Okay, so it is 3 times under root of FCI prime, sorry. So it is 3 times under root of 3750. Okay, I'm sorry, I picked the wrong one. Sorry, it is 6 times under root. I'm sorry, it is 6 times under root of FCI prime. Okay, so you get how much? 367. 367 psi. Of course, it's a okay. So 367 psi is the maximum tensile stress allowed over here. Okay, at the ends of a simply supported beam at the time of transfer. Clear? And the maximum compressive allowed was 2625, and right now the compressive stress is minus 2147. So both these are okay. So this is lesser and this is also lesser. Both are okay. So we have checked these limits B and D. We have checked these limits B and D at the ends of a simply supported beam. Okay. Although the statement in the book says that you do the checks for the midspan only, but of course you have to check for the ends as well. Okay. So that's why I didn't mention it, whether you need to check them at the ends or midspan. You have to check everywhere at all stages. Now, for but at the end, sorry, at the midspan, we will have to consider the self weight as well. Okay, we'll have to consider the self weight as well. So again, we need to check F1. So I'm going to write the whole expression instead of writing the simple answer. So I'm going to write M minus Pi over AC times 1 minus EC1 over R square. This is due to the pre-stressing alone at the top, and then when you consider the effect of self weight, we may have to do that somewhere over here. So M naught due to self weight would be WL square by 8. Where is that? 0.183 L square by 8. Okay. So 0.183 is the self weight intensity, W naught. L square, L is 40 feet. 40 into 12 makes inches square by 8. This will be the answer in kip inch. There is another way, maybe you can just keep it kip foot at the moment. Let's see if, yeah, you can work in kip foot, let it be foot, we will do the conversion later. Okay. So what is the M naught value? 36.6 kip foot. This is the moment due to self weight, and the stress due to this self weight would be M naught over S1 R2, and since S1 and S2 are same, so S1 is equal to I over C1, which is same as I over C2. So therefore S1 and S2 are same for the top and for the bottom. Okay. So we are going to use only single value over here, but you need to be careful. Okay. So we are doing it for the top, so I'm just going to write S1 just to make sure that if it is different, you can use the actual value. Okay. S1. It will be minus. So of course the answer is going to be same, plus 352. Okay, but I just wanted you to understand where is it coming from. Plus 352. This answer I've just copied over here. Minus M naught over S1. M naught is 36.6 kip foot, but we got to work in pounds and inches. So we have to multiply this by 1000 to make it pounds, and to multiply by 12 to make it inches. Okay, kip. When you go to pounds, it has to, you have to multiply by 1000. From foot, you want to go to inches, you have got to multiply by 12. So this is in pound inch now. The moment is in pound inch now, and S is in inch cube, so it is 1000. Now you can get your answer for the, sorry, 439 psi. You can just give me a whole number for the stress in psi. 439 psi. Okay. Sorry. 439 for, I'm sorry, 439 is for this one only, I guess. This is 439. What is the final answer? 352 minus 439. I'm sorry? Minus 87 psi. Okay, this is at the top. And at the bottom, so this will be, so I'm just going to copy this number for this expression, minus 2147 psi. Okay, and this number will be plus 439. So what is the answer now? Minus 1708 psi. Please, somebody else also check the answers. Minus 1708 psi. So this is compressive and this is also compressive. It's a bigger compression and this is smaller compression. Okay. Over here, so a tensile stress due to pre-stressing forces at the top, and we have a compressive stress due to the self weight, which ultimately becomes a net compressive stress. Okay, so there is no tension anywhere in the cross section right now at the midspan. Okay, these are at the midspan, of course, because this stress, this moment value is at the midspan. This answer for moment m naught is at the midspan. Okay, just to remind you, it is at the midspan. So of course, these stresses are also calculated at the midspan. So these are at the midspan, just to at midspan. Okay. At the ends, the answer still remains the same because this term is 0 at the ends. Okay, and we've already checked the stresses at the end for the limits. Clear? Ends are clear. We will never come back to checking the stresses at the ends of the simply supported member in the whole process. We are done with the ends. We will always be now focusing at the midspan. Clear? So now at midspan, you got to check F1 and F2. Well, the limit for the extreme fiber stress in tension immediately after transfer, I'm at parent number C. At parent number C, the limit is 3 under root of Fc prime. FCI prime, sorry. What is this answer equal to? (184 psi). This is the tensile stress limit. Okay, at midspan, I should say, for a simply supported beam. So we have got compressive stresses all over, so it's not going to be a problem. Okay, if it were to be tensile, it should not exceed this level. Getting it? If this is tensile, the maximum allowed value is this 184 psi. Okay. Anyways, and for the compression, it is 2250, and it's again within the limits 1708, 1708. So मैं आपको limits लिख रहा हूँ. This is compared with this. मैं lesser लिख रहा हूँ. Lesser का मतलब है ये जो compression है इस compression से छोटी है. ये ना क्या इसलिए नहीं कि ये negative है. Negative वाला चक्कर नहीं है. This is compression of 1708 and this is the maximum allowed value. ठीक हो गया. और वो जो 184 psi मैंने वहां पे लिखा है वो आपने कंपेयर करना है इसके साथ. ओके, दिस इज ओके एंड दिस इज ऑल्सो ओके. क्लियर हो गया आपको? तो हमने कंपेयर किससे किया? इन दो के साथ. जब हमने पी आई की वैल्यू यूज की थी. ये आंसर्स ऑथर ने बुक में नेक्स्ट स्टेप्स में कैलकुलेट करके रख लिए कि आगे जाके बस इसके साथ उसी के साथ सुपर इम्पोज करूंगा. अदरवाइज यू डोंट नीड देम. मैं जान के इसको मिटा रहा हूं ताकि आपकी कंफ्यूजन खत्म हो. ये मैंने आपको सिर्फ इसलिए बताया कि जो आपको ऑथर में जो आंसर्स कर रहा था ना 134 by 158, वो कंफ्यूजन दूर करने के लिए मैंने स्टेप कर लिया. अदरवाइज लिमिट्स अप्लाई करने की हद तक ये कैलकुलेशंस आपको इस वक्त चाहिए थी. आप हर दफा पूरी एक्सप्रेशन लिख के स्ट्रेस कैलकुलेट करें ताकि आपको पता चले कि मैं किन किन चीजों का अकाउंट करके कर रहा हूं. ठीक, बजाय इसके प्रीवियस रिजल्ट्स. एक्सप्रेशन एटलीस्ट लिखें, चाहे आप आंसर जैसे मैंने 352 वहां से बोरो कर लिया, इट्स फाइन, लेकिन एक्सप्रेशन लाजमी लिखें. यहां तक आप क्लियर हो गया? ये हमने एट द टाइम ऑफ ट्रांसफर चेक्स लगा दिए. ABCD चेक्स अप्लाइड, ऑल ऑफ देम आर ओके. व्हाट नेक्स्ट? जब पूरा लोड लग जाएगा, डेड लोड और लाइव, सुपर इम्पोज डेड लोड और लाइव लोड भी सारा का सारा लग जाएगा, और हमने अज्यूम किया कि हमारा सारा लाइव लोड सस्टेन्ड है. तो अब हमें सिर्फ एक और दफा F1 F2 कैलकुलेट करना है व्हेन ऑल ऑफ दोज लोड्स आर एक्टिंग. ठीक है, सो मैं इसको मिटा रहा हूं, मिटा दूं. So next is when full service load is acting. This is the second stage, second part of the problem. Okay. Now at this stage, you will calculate again the top and the bottom stresses. At the top, you can write again minus PE over AC. Now I'm writing PE because now I'm at the stage of full transfer, full service load applied. Okay, times 1 minus EC1 over R square minus M naught over S1. Okay, so this is due to the pre-stressing, this is due to the self weight minus MD over S1, this is due to the dead load minus ML over S1, this is due to the live loads. Okay, if the live loads has got two stages, you have to add another stage. You have to say when full service load, when only the sustained load part of the live load is acting, and the third stage would be when full service load is applied. सस्टेन लोड पार्ट इज एक्टिंग, उस स्टेज में फिर आप एमएल की वो वाला पोर्शन लिखेंगे जो सस्टेन्ड है और उसको करस्पॉन्डिंग लिमिट्स के साथ कंपेयर करेंगे. लेकिन हमारे केस में चूंकि वो सारा लाइव लोड हमने सस्टेन कंसिडर कर लिया, तो हम इसको हमारा स्टेजेस एक रिड्यूस हो गया, फुल सर्विस लोड इकट्ठा ही सारा हमने कंसिडर कर लिया. And then F2 will be minus PE over AC times 1 plus EC2 over R square plus M naught over S1 plus MD over S1 plus ML over S1. Okay. All right. So now you just need to put the values. Just confirm that you will get the answers you should get. You may have to calculate MD and ML. Okay, so I'm going to calculate them together because the total value is given. So I'm going to use 0.750, the intensity of the UDL due to dead and live together, times 40 squared, 40 is the span, by 8. So this is WL square by 8. Okay. What is the answer? So basically we are doing it together, but you should know that they are actually in parts. 186.6 kip foot. Okay. So minus M naught over S1, if you remember, it was 439. Sorry? How much? 150. That's it? Kip foot. Okay, that's right. Now what next? M naught over S1, that value I think it was 439. Okay, so minus 439. This is M naught over S1 divided by 1000, which is this S value. So you get your answer. And similarly, you will work it out over here. What are the answers? Minus 1940 psi, and what is this? Plus 418 psi. This is compressive, this is tensile, as expected. Okay. So you have to go back to table 22.1. Okay. go back to table 22.1 and can you figure out the relevant para? Which para applies?